I was wondering if I kind of stand here or
Kijk op die screen. Kijk op de screen, like it's so.
will you guys tell me what do, or should I either side for him? I don't know. Here.
No, we're not showing the audience.
People, we're basically focusing like that. So you won't get any of the head.
Okay. So it's just going to be here.
We're going to reach over to the presentation when there's something that we have to.
Yeah, we get a direct feed from these computers into ours.
If there's something we need to show, but we won't brief on that either. So we will, Maria has arranged that she said some of the slides have a lot of detail, which is but we won't brief on that.
Okay,
So we will.
is there anything you need to ask me so we can call it out here and clarify things? Or
Well, I don't know. No, I don't think so. We've basically got two cameras that you can but that's otherwise we'll
just
do
show
our
it?
best.
Yeah. Okay, no, I think she didn't give you a specific reason, and that's fine. I was just thinking for me to ask the questions, it's better that I am across from you or here. Yeah, it's better that I am here and I can ask the questions.
Do you have our the start slide? Your first slide. Do you want to put it on the screen?
So we're going to start soon.
I think so. There we go.
get close to you. She's going to sit here. She's going to put a bottle of water and glass here for her. She's going to sit here and she's going to hold a picture so that when you talk and she wants to ask you a question, she can just interact with you. Yeah, that's fine. And we're going to be in the shot of. This is not too tall. Block the whole presentation. question we ask daily: what is the weather forecast? But today we're taking it a step further as we explore meteorology of the future. How
question. I when I was a student, I don't know what will I do, because I'm just a student. Maybe I will do one thing, maybe I will do another thing. But actually, I spent like 8 years in science. 5 years spent from the Moscow, and they asked me in the university, you live near the city, right? You will go to this organization and travel to Central Aerological. I started my diploma there, and my future supervisor, scientific supervisor, just came back from Japan, and in Japan there was his friend that did new project about greenhouse gases observations. So they need students, and they ask if I can join this project. And I started to work with Japan on greenhouse observations, and I actually got a PhD in this field because we're trying greenhouse gases. And one day I, with my colleagues and friends, decided that, oh, we're scientists, we can do everything, let's monetize our knowledge. And we decided to build a startup, because we know everything about greenhouse gases transport in the atmosphere. So we decided that we should know air condition in every point on the planet, and we can provide pollution forecast for the several days. But we were scientists, and we didn't market fit, and we decided we will build great technology, and then we will decide how to monetize it. Yes, and we built great technology, but there were problems with monetization, because only in California the people were air, and now, for example, in Google Weather you can find information about air quality forecast. Actually, they bought our competitor breathometer, and we were run out of the funds, and in one stage of our startup, we came to Yandex. Yandex is like Russian Google because actually it started from the search. We like the most popular search engine in Russia. We're more popular than Google, but Yandex not only search now. We have like music like Spotify. We have taxi service like Uber. We have online marketplace like Amazon and so on. So Yandex is a large IT company, and like 10 years ago, they decided that there is a scientist that could build a technology for weather forecasting system and to use machine learning to improve weather forecast. So I, with my team, started to build the technology that we call Medium, that provides weather forecasts all around the world using machine learning or artificial intelligence. Do you have... okay.
Due to the development of their weather forecasting system, which eventually resulted in the creation of Meteor. Can you share with us your journey at Yandex? What do you think attracted them to you, and what's set your approach to weather forecasting apart from others in the field?
Can you hear me? Okay, I will think. I speak in this microphone. So yeah, in Yandex, this time they decided to build their own weather forecast because it was in 2014. Yeah, it's almost 10 years ago, and they use weather forecast from Finland. So they just buy the weather forecast from another weather service, and now usually IT companies try to provide weather forecasts and to build their own technology, and here is my plan of presentation for today, and I will tell you about that in this presentation.
Okay, great. And then just another question. So we all use weather apps, and we've all experienced moments where the forecast was wrong.
Yeah, sure. And to explain this, what is the common between ChatGPT and weather forecast, and why IT companies try to build their own weather forecast. To start this conversation, I want to interact with you, and I ask you about question, why do we need weather and forecast? What do you think? Yeah, sure. And the first point, to know what to wear. The second, to start a conversation, because I was using Bolt today, and driver said it's hot today, isn't it? That's why we need weather and forecast. Any other opinions?
In Cape Town, because I'm sure you would have experienced that it changes all the time. Like one day it's very hot, and cold. So because wind here is also a thing. How can I know if I'm going to go to the beach? Yeah, it's very important.
Yeah, but the second point was don't get wet, but I'm not sure. No, 3 days ago there was a rain, so don't get wet. And the third point is to use cable cars in Table Mountain because of the wind. Because as far as I know, you cannot go to the mountains by cable cars if it's windy conditions. Or if you look at me, don't forget to use sunscreen when you go to the Table Mountain, or you will get such a red face like mine. That's all, and also for aviation, green energy, logistics, sales, agriculture, emergency services, and more, and also to train large neural networks, because like we discussed before, Yandex and other IT companies decided to build their own weather forecasts. Why? So here are examples. IBM bought Weather Channel, but they already sold it. Apple bought Dark Sky, and Google, Microsoft, Amazon, and Huawei, they are working on their own weather forecast based on AI. So, why? The simple question, because they can. We young scientists, we can build technology and we can, but the answer is complicated, because usually there is no necessary flexibility, sometimes accuracy and fault tolerance, and no focus for the business needs. And sometimes we have outdated standards in meteorology. And also the answer is because atmosphere is a great source of data. I don't know, do you use ChatGPT? And it was possible several years ago to start using this this product, but large language models were maybe 10 years or maybe more, and only after 3 things they started to be smart. And the first thing is if you have a large amount of data to train your model, for example, ChatGPT 3.5 was trained on Reddit, on Wikipedia, and other sources in the internet. And the second and the third, because ChatGPT, a complex model, they added more parameters, and because they adopt answers of the people, they label it data in that way that people get the answers that they expect. But the first thing, because they have a lot data in the text from the internet, and the same for the atmosphere. Atmosphere is a big source of the data, and that's why we can use the same approach that IT companies use for ChatGPT to provide information about weather. And in the next, I will explain you why there are so much information from the atmosphere and how we can collect this data, and I can answer your question after that, because it's difficult to explain if you didn't explain everything how it works. So the main question is, what is the weather? What do you think?
What's happening today?
You're right, because the weather is a specific condition of the atmosphere in the specific point and at the specific time. Usually you can get some information about cloudiness, precipitation, pressure, humidity, temperature, and so on. And usually, what do people think about weather measurements? That there are super systems that can collect data from everywhere, and it's like digital and so on. But actually, the main data that we get about the atmosphere collected on this kind of weather grounds. It's in Moscow. On the background you can see Moscow State University, and this is one of the weather stations in the Moscow. And here in the hands of this man you can see this bucket. And what do you think is it?
It looks like a watering can.
Uh,
You water plants with, but I don't think it is that.
yeah.
No.
And the answer?
I think it's a rain gauge.
Yeah, yeah, it's a rain gauge. And usually, if you hear in the weather forecast that there were like 10 millimeters of rain today, usually that it means that in this bucket, this man pour the water in some glass, get the ruler, then he measured 10 millimeters of the water, and this is like the most accurate data about precipitation we have, because the other data I will talk you about, it's not direct measurements, it's like indirect measurements. And on the here you can see this place where usually temperature measured because it's sun protected. And also here in Cape Town, do you recognize the place? What is it? Yeah, that's where I get my red face. And as you can see, here, and here, there are like weather equipment. It's automatic, as I can see. So not only by the measurements, not only taken by the people, but in automatic mode. And I think you can see the weather from these devices on website of the Table Mountain. And also we have not only weather stations on the ground, we have radio zones. It's like large balloons then, that you can fly up to 20 kilometers and to measure the vertical distribution of temperature, humidity, and so on. We have ships, buoys, satellites, and even if you have a flight in aircraft, then you measure weather because in aircrafts there are some weather equipment, and when it was lockdown caused by COVID, there was no aircrafts. And usually to see the weather forecast on the TV or in your smartphone, this data goes on very, very complex way. This is a simple approach. For example, we have weather stations, and we collected information about different kinds of temperature, pressure, and so on. And then that we call magic of forecasting, and in science we call it primitive equations. It's on one side it's primitive, but you cannot solve it directly. So it's very, very complex equations, but if you solve it, you can get information about temperature, for example, tomorrow. And usually to provide information of the weather tomorrow, you need to solve these equations like on supercomputers, and you need like to imagine like Death Star from Star Wars, and imagine that it built from Lego cubes. So we need these Lego cubes like cells in the atmosphere, in which one we need to solve these equations. And in each cell or in which cube we solve this equation, and we provide like information about weather for tomorrow. And usually these models run on supercomputers. The calculation for 10 days takes around 6 hours. The resolution, temporal resolution is about 1 or 3 hours, and spatial resolution 10-25 kilometers. But if we need to get a better forecast, we need higher resolution. So, for example, caused by topography, because if you have like low resolution, your topography is not described well. So you cannot describe not only process caused by topography, but also on the different scales you cannot predict tornado, local winds, and so on. So the better resolution you have, the better forecast you have. But the better resolution you have, you need more computers to calculate this forecast. And I think you have another question.
Yes. So we hear more and more about melting glaciers, rising temperatures, and even unexpected rainfall in the Middle East. And AI allows for more accurate models, right? So could you share what you foresee for humanity as it relates to climate change and how AI can help mitigate some of the impacts?
Yeah, sure. Why do we need AI? Not only because we can, but also because we have like errors in the models, and as far as you can say that the weather forecast is not absolutely correct. So you cannot get the ideal forecast for 10 days. There are good forecasts for like 3 days. And this caused by that, first of all, there is, you cannot measure weather everywhere, and you cannot measure it with without errors, because, for example, if you measure temperature, there will be an error about 0.5 degrees or 0.5 degree, depends on weather station. Also, to solve these equations, you need like supercomputers, and you need like approximations to solve this equation, and topography in the models, and there are time and space averaging. So that's why the farther you go in the future, the more errors you will get in the forecasts. So that's why we started to use, not only we, but as you can see now, many IT companies started to use artificial intelligence to improve the weather forecast. For example, we can calculate the forecast with different models. There are like 10 independent global weather models in the world, and you can take, for example, we take 5 of them, and every model will have different forecast. For example, one says it will be 20 degrees, second says it will be 25 degrees, and so on. Also you can add some other data like sun elevation that affects the weather condition. You can add altitude above sea level. You can add distance from the city center or distance from the ocean, and you have a large combination of different forecasts and different data. And then you can show, in these kinds of conditions, in weather station, we get like 21 degree. And we can train a model or artificial intelligence to reconstruct the combination of different data to provide the more accurate weather forecast. So that helps to reduce prediction errors and increase the resolution. And as I said previously, you need good resolution to provide information about weather, especially in the places like Cape Town, because here is mountains nearby, and the weather could be unpredictable. And so if you look, it's not good here, but on the left side you can see some anomalies here, because it's smoothed globally, and it's have poor spatial resolution. And if we refine with artificial intelligence, we can provide greater spatial resolution. And that's why we can provide globally resolution 2 by 2 kilometers, and in mountain areas we can provide up 200 meters resolution, because in the mountains when you go up, the temperature drops down, and you need to get information about it. And actually here you can see there is European model, US model, Canada model, and Japan global models. And this is mistakes of the models globally. And Meteor is a forecast provided by machine learning or artificial intelligence, and you can see that the accuracy is better than using traditional approach. I think I can tell more, but maybe I don't know what is the next question.
Okay, so just a question. Explain to new acquaintances what you do. Do you often encounter the misconception that meteorologists are simply people reading weather forecasts on the news?
Okay, I don't have this on my slides, because there are about climate and about nowcasting. It's about forecast, every 10 minutes you can get information about the rain. But about your question, could you repeat, please?
How difficult is it to explain to new acquaintances what you do? Do you often encounter the misconception that meteorologists are simply people reading weather forecasts on the news?
So the question to the audience, is it complicated to understand what I do? It's complicated. Okay. That's why we have a big team. We have not only like people who read weather in the TV on news. We have like meteorologists that work with this kind of data. We have backend developers, software developers. We have machine learning developers. We have engineers. We have product and project management managers. We have designers. We have analysts. So this team like work together to help me to describe what we are doing and to provide information in like weather app, for example.
Okay, great, thanks. And from the audience?
You also use like a platform like ChatGPT for just weather forecasting. Like, do you have a program where you just add in your questions and the program does your calculation for you?
It's a good. For example, if you need to provide information about weather, you need to provide like actionable insight like ChatGPT does. Because if you provide information like tomorrow will be 25 degrees, for example, for business, it means nothing because you need in-house team that can explain what does it mean for the business. And usually we provide information in such form, like expect this is the case for transportation. So expect like expect delay in deliveries of some parcels and so on. So we try to provide like ChatGPT like answers to our clients.
So I was wondering, do you guys only deal with, okay, so if you said weather is just the day-to-day, like specific to a very specific time and place, do you guys deal at all with like the larger picture of like climate change sort of thing? And like, I'm sure you guys have a lot of data. Do you kind of share this data? Because I'm sure you guys have a lot of insights into the bigger picture of things. So
Yeah, sure. It's
yeah,
it's a good question because the same approach that we use for weather forecasting we can use for climate projections and climate risks because, for example, scientists provide more than 100 models from 50 global modeling centers, and for example, the last one project called Couplet Model Intercomparison Project 6, but here you can find like different scenarios of the climate change, and in this picture you can see that in initial stage the scenarios are pretty the same, and further we go in the future these scenarios became more and more unpredictable. So if we have like hundreds of scenarios and we know what the weather and what the climate now, we can use the same approach to provide the better approximation of climate change and climate risk to the business and to the people.
Thank you. I think we have one more question.
Thank you very much. Actually, I understand that ChatGPT, artificial intelligence, works on the principle of damaging the child. So, the quality of
any artificial intelligence work on this principle.
yeah. So, my question is, there are hard-to-reach areas. Maybe find, because you have shown us, actually, the data we think is so scientific is related from I would say primitive, no, not, but that's what I would use, primitive tools, wind gauges and small things, wind vanes. So how do you get data maybe from a hard-to-reach area like Ipite, Namib, Desert, Kalahari, to your database, and it's processed online, and it's processed immediately, and you analyze it and give up-to-date accurate information? That's the complexity that I would like you to explain to a layman.
Yeah, thank you for your question. We have not only primitive devices, and here, for example, one moment. Here, for example, we have weather radars that can provide information about rain. It works like you emit some. If we see like raindrops in the cloud, the weather radar, and you can get information about like in this kind of map, like around this weather radar. And but it's a pity that weather radars located not everywhere. For example, in Russia, they are located like in the largest cities, and there are only like radars. As far as I know, in South Africa there is one weather radar. Maybe I have mistake there, but I have checked World Meteorological Organization site, and it says that there is only one weather radar. So we can use not only this kind of data, and we do it in Russia, but we can use, for example, geostationary satellites. This kind of satellites, like on the special orbit, when the satellite rotates with the same speed that the Earth can rotate, and it's like a big photo camera in the space that looking at the one point, and you can got the information all over the world. For example, we use like information from 3 satellites that cover like United States, US, Africa, and Europe Meteosat satellites, and Asia and Australia Himawari satellites. And good news for South Africa, that South Africa is located in like a green zone of this. A picture on your camera, you can see some distortions on the borders of the picture, and if you go from the center of picture from satellites, you will get the low resolution, and we cover like different, the most populated this kind of satellites cannot cover like the north part of the Russia. But for example, if we use weather radars, we have like small coverage. And but not only that, because as you said, garbage in, garbage out. Weather up about weather condition. For example, if we show on the right it's a city between European and Asian part of Russia. Yes, I'm ready.
What is your favorite book?
My favorite book, not only one book, but novels from James Fenimore Cooper, about Indians. Like the most famous is The Last from Mohicans. Maybe that's why I decided to start to work with weather, with geography, and so on, because I like adventures from, like I read this book in school, I think, and like one book, it's like this one, and there were like 5 books, and I really like it.
Amazing. What question in climatology or meteorology would you like to have answered most?
I don't know. Did you see the movie Back to the Future? And I think in the second part, Doc drives DeLorean with Marty, opens the door, and like looks at his watch and asks Marty not to go outside the car because rain started in that moment. And I hope that one day we can provide this kind of accuracy for people and for business. And this is my dream to come this movie true. Not only traveling in the future, but also provide correct weather forecasts.
Great, thank you. What is your favorite character from The Big Bang Theory?
Sheldon Cooper. Because it's like me, he has crazy ideas and he thinks like logical. It doesn't help him to communicate with people, but I understand him.
How do meteorologists spend their free time?
Good question. If I have free time, but usually I like to travel. For example, my vacation I decided to spend in South Africa. I like to go for running. I want to run like a marathon. I like to drive a bicycle. I like to mix cocktails for my friends, and sometimes we provide some parties for colleagues, for friends, and so on. That's what I'm doing in the free time when I have free time.
Okay, great. And last question. If you ever wanted to change fields, what would you do?
In the school, I could be like a sportsman because I was good at football. I don't know here in South Africa, soccer or football, soccer, in soccer, because I like to play this game, and also biathlon. I don't know, do you know what kind of sport is it? It's like you skiing and you fire in the target. That's why biathlon, because you have two kinds of activities. But in the school, I get my glasses and I cannot hit the target great. So I decided to go in this kind of activities to the science, but in the science I could be like a nuclear physicist because I studied at National Nuclear University in Moscow. Now it's called National Nuclear University. The previous name was Moscow Engineering Physicists Institute. But actually, when I was on the third year of education, previously we don't have two-stage degrees like I think you have here. We need to provide in university 5.5 year, and you will get degree of specialist, we call it, not master and so on. It's like between master and bachelor. So on the third year of education, you decide in which department you should go, and I have a chance to go to Department of Theoretical Nuclear Physics, but I decided to go to I tried to remember the name, simulation of environmental process in atmosphere. That's why I'm here now.
All right, thank you very much. Thank you, everyone, and thank you for your time today, Alexander.
Thank you for your questions. And if you want to be a forecaster and to provide weather reports, I will be honest that we don't have much users here in South Africa. But if you decide to download our app, you can improve the weather forecast by reporting to us. If you want to contact me, this is my email and LinkedIn, so it was my pleasure to talk with you. Thank you.